Hello everyone, myself Ashutosh and I along with my friend Mudit Gupta will be demonstrating our art gallery problem and this is the main Jupyter notebook that we will be running. This is kind of a main file. So this cell is just for importing libraries. So now we have imported libraries. Now all the test cases that are there in the report. So all of those test cases are here as well. You can just uncomment and use those test cases. So let's start with this one. We have a random heptagon. I've just selected 7 random points. So let's load this data set. As you can see, number of points in polygon is 7. Now let's construct a simple polygon from these points. So this polygon is constructed. As you can see, it has 7 points. Now let's construct the monotone partition of this polygon. So as you can see, this diagonal is added. Now to show intermediate steps of the sweep line algorithm, what our code does is that in this specific folder, monotone partition steps, it adds all of the intermediate images. So this is the first sweep line kind of, this is the first sweep line event. This is a start vertex. Then the second vertex is also start. Then there is this regular vertex. Now this merge vertex, there will be a diagonal will be added onto this merge vertex later. Now in this regular vertex, as you can see, the leftmost edge is the closest left edge is this one, and whose helper is this. And as this vertex is merged, we add a diagonal. This vertex is a regular vertex, and finally this one is the end vertex. So this diagonal is added. Now let's triangulate the monotone polygons. So we have added 3 more diagonals to it for triangulating. So all of these nice triangles here. Now from this triangulation, we first generate the dual tree. Then from the dual tree, we recolor all of the vertices and then report the number of guards. So as you can see, this dual tree has been created. Then using this dual tree, we have colored our polygon. RGB colors have been used. And then as you can see, there are 3 green vertices, 2 blue and 2 red vertices. So 2 guards are sufficient. We choose all the red colored guards and those guards are placed on this point. As you can see, these three triangles are visible from this vertex and these 2 triangles are visible from this vertex. Now for a more complicated case, I hand over to Mudit Gupta.
Hello everyone, I'm Mudit Gupta and I'll be showing you the execution for another example. So let's run this. This time we are running our algorithm for 25 points and we create this simple polygon. This is a simple polygon and then we do the monotone partitioning on it. So this is the monotone partition of the polygon. We can see that all the different faces of this polygon are now monotonic. And now the next step is to triangulate this monotone partition. So on triangulation, we get this image, and we can see that all the faces are triangles. So now we'll do the last step. For the last step, we'll do 3 coloring on this triangular mesh. So to obtain that 3 coloring, we first construct this dual tree of the various faces in the triangulation. Then we color each triangle one by one and we get this coloring. You can see that no 2 adjacent vertices have the same color. Now we choose the green colored vertices as the guard because they have the minimum count and we get these guards. We can also verify that all these guards uh, cover the whole polygon. So now Okay, so now I'll be showing you the execution on some randomly generated points. So here we generate 20 random points. I'll just comment this out. Now since the points are not already sorted, so we have to sort them. Now I'll run all the cells and directly see the output. This is the simple polygon generated, and for the monotone partition, so this is the monotone partition of the simple polygon. Now next step is triangulation. This is the triangulation obtained, and this is the dual tree generated for the triangulation, and this is the three coloring for the triangulation. And so these are the guards required. So we require 5 guards. So that's it for the demonstration of our algorithm.